The journey begins with harvesting the rootstock, which forms the underground part of the future vine. Rootstock varieties are chosen for their resistance to soil pests, diseases like phylloxera, and adaptability to specific soil types. During dormancy, usually in winter, rootstock canes are collected from dedicated mother plantations. Harvesting must be performed carefully to avoid damage, ensuring the canes remain fresh and viable for the grafting process ahead. Once harvested, the rootstock canes undergo a crucial preparation stage known as bud removal, or debudding. The purpose is to eliminate any existing buds that could sprout and compete with the scion later on. Workers meticulously remove these buds using specialized tools, leaving a smooth surface on the canes. This step ensures that only the desired grape variety, which will be grafted onto the rootstock, will grow and produce shoots. Next, the rootstock canes are cut into segments of specific lengths, depending on nursery practices and market requirements. Typically, each segment will become one grafted cutting. Standardizing the length is vital for uniformity during planting and for the mechanical handling of the cuttings in subsequent stages. The prepared rootstock segments are sorted by diameter to ensure uniformity and compatibility with the scion pieces they will receive. Two main categories are usually established: diameter from 10 to 12 millimeters, diameter from 6.5 to 9 millimeters. Uniform diameters are critical because they enable a precise fit during the grafting process, increasing the chances of successful vascular connection between rootstock and scion. Before grafting, the rootstock segments undergo disinfection, typically using solutions such as hot water baths or chemical treatments. This process eliminates pathogens, fungi, and bacteria that could cause diseases. Disinfection ensures the sanitary health of the future vine and helps maintain the high-quality standards required in modern vine propagation. While rootstock preparation takes place, scion wood, the shoots from grape varieties intended for wine or table grape production, is also harvested and processed. The scions are cut into small segments, each bearing 1 or 2 buds. These segments will be grafted onto the prepared rootstock to create the desired grapevine variety. Similar to the rootstock, scion wood undergoes disinfection to eliminate potential pathogens. Clean scion wood is vital to prevent disease transmission and to secure a healthy start for the new grafted vine. Grafting is the pivotal moment in producing rooted, grafted vines. Skilled workers join the scion to the rootstock using methods such as omega grafting, whip and tongue grafting, or machine-assisted techniques. The two parts must align perfectly, ensuring that the cambium layers, the tissues responsible for growth and nutrient transport, of both pieces make intimate contact. This connection allows the rootstock and scion to grow as one unified plant. Immediately after grafting, the grafted union is sealed with paraffin wax. This waxing process prevents dehydration, protects the graft from infections, and maintains moisture around the graft interface. The wax layer also shields the delicate graft from physical damage during handling. Before the grafted cuttings are rooted, they undergo preparation for a process known as forcing. The cuttings are bundled and conditioned under controlled humidity and temperature to stimulate callousing, the formation of undifferentiated tissue at the graft union that will develop into vascular tissue. Forcing takes place in greenhouses maintained at warm, humid conditions. This environment promotes rapid callus formation and the initial union between scion and rootstock. The forcing period typically lasts a few weeks, depending on vine variety and nursery practices. After forcing, the grafted cuttings are cleaned to remove excess callus tissue and any abnormal growth. Cleaning ensures that the plants are uniform and that the graft union remains healthy and free from infections. A second waxing, known as pre-planting waxing, coats the entire cutting or its upper portion. This step further protects the graft union, reduces water loss during planting, and minimizes the risk of mechanical damage during handling and transport. Before planting, the nursery field is prepared with mulch film and a sub-irrigation system. The mulch film suppresses weeds, maintains soil moisture, and improves soil temperature for root development. The sub-irrigation system delivers precise water quantities directly to the root zone, promoting uniform growth and reducing water waste. The waxed grafted cuttings are then planted into the nursery field, either manually or using specialized machinery. Planting depth and spacing are carefully managed to ensure proper root development and optimal growing conditions for each cutting. As the young vines grow, unwanted shoots, known as suckers, may emerge from the rootstock. These must be removed periodically to ensure that only the scion variety develops into the future vine. Sucker removal is essential for producing a uniform and high-quality vine, ready for sale to vineyards. Through these steps, rooted grafted vines are produced, ensuring the health, vigor, and genetic fidelity of vineyards worldwide. The process combines traditional craftsmanship with modern technology, reflecting centuries of viticultural expertise and innovation. The manufacturing of coir-based growing media begins with the coconut husk, a natural byproduct from coconuts harvested in Sri Lanka, a country renowned for its rich coconut industry. The process starts with dehusking, where the fibrous husk is separated from the inner nut. These husks are sourced from the manufacturer's own plantations and registered suppliers to ensure quality and traceability. Next, the husks undergo decorticating, a mechanical process where machines extract coir fiber and cocoa peat, also known as coir pith. Alternatively, husks may be cut into chips. The extracted cocoa peat is then subjected to thorough washing and drying to remove excess salts and impurities, crucial for creating a clean and stable growing medium. The material is tested and graded for properties like pH, electrical conductivity, and particle size to meet stringent quality standards. High-quality machinery precisely decorticates, sieves raw materials, removes impurities, mixes components, and compresses products. Latest technologies and strict parameters ensure uniform quality, purity, and efficiency. A judicious eye for quality means constant vigilance throughout production. Skilled technicians and quality control staff meticulously inspect every stage, from raw husk selection to final packaging. They evaluate color, texture, moisture, pH, and electrical conductivity to ensure uniformity and safety for plants. Advanced lab testing identifies contaminants or inconsistencies, while visual checks catch physical impurities. This dedication guarantees each batch meets international standards, fostering customer trust and maintaining the brand's reputation for clean, premium-grade coir growing media worldwide. Spread coconut fiber thinly under sun to reduce moisture evenly. Workers carefully load dried coconut fiber into trucks for transport. Inspect fiber's moisture content, color, and cleanliness for quality assurance. Transport checked fiber batches into factory for further processing steps. Workers carefully unload dried coconut fiber from vehicles, ensuring fibers remain intact, clean, and ready for smooth transition into machinery processing. Employees manually feed the dried coconut fiber into specialized processing machines, spreading it evenly to prevent blockages, ensure consistent flow, and maintain uniformity in the subsequent compression and baling operations. The dried coconut fiber undergoes 2 stages of compression using powerful hydraulic presses. The first press reduces volume significantly, while the second press ensures denser packing, creating uniform bales that are easier to handle, store, and transport efficiently. Compressed fiber bales are tightly secured with durable plastic strappings, ensuring they maintain shape, stability, and safety during storage, handling, and export shipping. Finished bales are organized and stacked neatly in the storage area, protected from moisture and dust, awaiting inspection and export shipment schedules. Workers carefully load the highest quality coconut fiber bales into shipping containers, arranging them securely to maximize space, prevent shifting during transit, and ensure products arrive safely for international customers. Rural India, which is home to approximately 833 million people, nearly 69% of the country's population, represents the true essence of India. The transformation of rural infrastructure, especially through road connectivity, has played a vital role in improving the socio-economic conditions of rural populations by enhancing access to education, healthcare, markets, and employment opportunities. Despite significant progress under initiatives like the Pradhan Mantri Gram Sadak Yojana, PMGSY, about 35% of rural habitations still remain unconnected by all-weather roads. The task of reaching these scattered, often remote areas is challenging due to India's diverse geography and soil conditions, limited access to traditional construction materials, and the high cost of conventional road-building techniques. In response to these challenges, the National Rural Roads Development Agency, NRRDA, in collaboration with research institutions and technical bodies, has introduced innovative and sustainable technologies tailored for rural road construction. Among these, the use of Coir Geo-textiles has emerged as a standout solution, offering a perfect balance of cost-effectiveness, ecological sustainability, and practical efficiency. The implementation process begins with the proper preparation of the subgrade, ensuring optimum moisture and 100% compaction. The Coir geotextile is then unrolled over the compacted subgrade, with careful attention to proper overlapping, alignment, and fixing with clamps or ties to prevent shifting. This is followed by layering the sub-base and base courses, involving gravel or crushed stone, compacted to design thickness and camber. The top surface is constructed using bituminous materials, such as natural rubber-modified bitumen, or VG30 grade bitumen, depending on project requirements. This layered structure, reinforced with Coir geotextiles at its foundation, significantly improves durability and performance over time. Although Coir is biodegradable, its effective life is over 5 years, long enough for the road structure to stabilize and for the subgrade to gain sufficient strength. Even after the Coir degrades, the road retains its structural integrity, having already derived the full benefit from reinforcement and drainage during its critical early years. Coir geotextiles are natural fiber-based materials made from coconut husk. India, particularly the coastal state of Kerala, produces nearly 66% of the world's coir fiber. These fibers are processed and woven into mats or meshes that can be used in road construction for reinforcing soil and improving drainage. Their production supports local industries and creates employment opportunities, especially for women, making them a livelihood-enhancing innovation. Unlike synthetic geotextiles, which can degrade under UV exposure and pose environmental hazards, Coir geotextiles are biodegradable, renewable, and eco-friendly. When used in rural road construction, they serve multiple roles. Reinforcement. Placed above the subgrade, Coir geotextiles improve soil strength and help distribute loads more evenly, reducing deformation. Separation. They act as a barrier between subgrade and aggregate layers, preventing the mixing of materials and maintaining the integrity of the pavement structure. Drainage. With high porosity, up to 40%, Coir geotextiles allow water to pass through while retaining soil particles, ensuring proper drainage and minimizing erosion. They also possess desirable physical properties such as a high coefficient of friction, high elongation, 30%, and resistance to saline water, making them suitable for diverse terrains. Proven success and future potential roads built using this technology, such as those in the CocoGoods district of Kerala, stand as tangible proof of its success. They demonstrate that eco-friendly, locally sourced, and economically viable solutions can deliver high-quality infrastructure. The tropical island nation located in the Indian Ocean is widely renowned for its rich agricultural heritage and fertile soil. Among its many natural treasures, coconuts have held a place of importance for centuries. Thanks to the country's tropical climate and traditional farming practices, Sri Lanka is recognized globally as a premier source of high-quality coconuts. One of the most valuable products derived from this natural bounty is extra virgin organic coconut oil, prized for its purity, nutritional benefits, and versatility. The production of this oil is a careful, multi-stage process that combines traditional knowledge with modern quality standards, all while maintaining a strong commitment to organic principles. The journey of extra virgin coconut oil begins in the coconut plantations of Sri Lanka. Unlike conventional farming, these plantations use only organic fertilizers, avoiding any chemical inputs. This eco-friendly approach not only protects the environment, but also ensures that the coconuts grown are as natural and wholesome as possible. Once mature, the coconuts are hand-harvested and transported to the processing facility. The freshness of the coconuts is crucial, as it directly impacts the quality of the oil extracted. Only clean, ripe coconuts are selected for processing. At the factory, the production process begins with the removal of the outer husk of the coconut. This tough, fibrous layer is peeled away to reveal the hard inner shell. The shell is then cracked open to access the white coconut meat inside. After this, the thin brown skin that lines the inner surface is carefully peeled away to produce pure white coconut meat. This delicate step is carried out by trained staff who have undergone in-house training to ensure precision and consistency. The peeled coconut meat is then subjected to multiple rounds of washing to ensure it is completely clean and free from any contaminants. This repeated washing process is carried out under strict supervision. Each batch of coconut meat is inspected by quality control officers to guarantee that only the highest quality raw material is used for oil extraction. Once cleaned, the coconut meat is cut into small flakes using specialized machinery. This shredding process makes it easier to remove moisture and extract the oil. The flakes are then transferred to a dehydration unit, where all moisture is removed. This is a crucial step in the process. Removing 100% of the water content ensures that the final oil is fresh, pure, and has a longer shelf life. With the moisture eliminated, the dry coconut flakes are ready for the oil extraction phase. The flakes are fed into a mechanical expeller, which presses out the oil without the use of heat or chemicals. This cold press method preserves the natural aroma, nutrients, and flavor of the coconut oil, resulting in 100% pure, colorless, and transparent extra virgin organic coconut oil. The extracted oil is of exceptional quality. It retains the coconut's natural nutrients, making it highly valued for its health benefits. Extra virgin coconut oil is known for its antioxidant properties, immune system support, and potential to prevent various illnesses. It is commonly used in cooking, skincare, hair care, and even in natural remedies. After extraction, the oil is sampled and rigorously tested to ensure it meets international standards of purity and quality. Once the quality is confirmed, the oil is sent to the packaging section. It is poured into sterilized bottles under the supervision of trained quality control personnel. Every step is carried out with attention to hygiene and safety, to ensure that the final product is suitable for both local and global markets. The filled and sealed bottles are carefully packed to prevent damage during transportation. These bottles are then shipped around the world under the Kokoma brand, a name that has come to symbolize premium organic coconut oil from Sri Lanka. Each coconut undergoes rigorous inspection for size, meat thickness, and freshness, ensuring only premium coconuts enter the production process. Plant workers follow strict hygiene protocols, including wearing sanitized uniforms, hair nets, gloves, and masks, and undergo regular health checks to maintain a clean environment and prevent contamination during production. During the final detailed quality checks, trained staff carefully inspect the cleaned coconut meat for any impurities, discoloration, or defects. Samples are tested for moisture content, fat composition, and potential contaminants to ensure compliance with international food safety standards. Any substandard material is removed, guaranteeing only the purest, highest quality coconut meat proceeds to the cold press extraction stage for oil production. Jars are sterilized with high-temperature steam before filling. Sterilized jars are precisely filled with oil using automated machines. Technicians perform continuous tests ensuring purity, safety, and consistency. Jars receive branded labels, then grouped into cartons for shipping.